everyone, I received multiple requests to go over domain and range once again. So I would like to take a look at numbers 33 through 41 on your quiz review worksheet. Starting with number 33, we have the equation y equals negative x squared plus 2. So if I take a look at the graph here, I can see that there's a vertex or a maximum of 0, 2, and the parabola is opening down. Remember, with a parabola, the domain will always be all real numbers, because as I look at the left side of the function, it's defined forever, and as I look at the right side of the function, it is defined forever. It's going to keep going and going and going. However, the range will be restricted because there's either going to be a highest point, so a maximum, or a lowest point, a minimum, thus restricting the amount of y values that it actually can be defined at. The range in this specific problem, remember if I'm writing it from down to up, would be negative infinity with a parenthesis because the bottom of the function is going down forever, and then it'll be to positive 2 with a bracket. I'm using the 2 because range corresponds to the y values. Essentially, this is what your answer should have looked like for number 33. Number 34 is a cubic function. Honestly, before I even graph it, I know what the domain and range is. Remember, I said in class, any cubic function will have a domain and a range of all real numbers. So let's look at the graph and see why that is. Okay. For this cubic function, as I move to the left, so I'm looking at the left-hand side of the graph, it's always defined. As I'm looking at the right side, once again, always defined. It's going down forever, it's going up forever. I mean, all around, like I said, all real numbers. Keeping that in mind, if I'm looking at all of the other equations, I see another cubic here, which is number 37 on your quiz review. This also would have a domain and a range of all real numbers. And also, right here, this is number 41. It would have a domain and a range of all real numbers because, once again, it's a cubic function. You should have written your answer for either 34, 37, or 41 using the R symbol or interval notation. Okay. Cubic functions weren't the only functions that had all real numbers for domain and range. We also discussed that linear functions would have a domain and range of all real numbers. So this is number, let's see, 39. So number 39 on your review. I'm pulling up how we should have wrote it once again. 1 second. Okay, here it is. So for number 39, you use the R or the interval notation. Looking at the graph, left to right, it's always defined. Down to up, always defined. Okay. How about we take a look at this equation right here? This is number 35 on your quiz review. Now, this is a square root function. The square root function has a clear starting point at 2, 4, and it will extend in this direction forever. When you're writing domain and range, remember, domain must be written left to right. Range must always be written down to up. Let's start with domain here. The furthest left this function can go is here at the starting point, which once again is 2, 4. because it's domain, I know I need to use that 2 value. And it's going to go to the right forever, towards a positive infinity. Range is down to up. The lowest point on this graph, once again, is a starting point. Now this time I'm going to use the 4 because range uses the y values. And it will go up forever. This is how you should have wrote your interval notation, using a bracket on the 2 and the 4 because these were coordinates for your starting point. And then parentheses with the infinities because that's something we cannot obtain. It's not included on our graph. Next, we have number 36. This is a quadratic function. We already looked at one for number 33. So I want to remind you the domain we automatically know is all real numbers because it's a parabola. And the range is restricted. This time it's restricted by a minimum. And that minimum is located at -2, 0. Now, because I want to look at the range, we need to be using that 0. Down to up, 0 is the lowest point on this graph, so the 0 must come first with a bracket because it is included on this graph. And it's going to go up towards positive infinity. Essentially, this is what your answer is going to look like for number 36. Number 38, I know I'm jumping around a little bit, but number 38 is this equation right here. Another square root function. It does have a starting point at 0, -3. Now this time, the square root function has a starting point and goes down forever. The square root functions, the domain and the range are restricted. So let's start with the domain. Reading the graph left to right, the furthest left this graph will go will be to an x value of 0, which I would use a bracket for. As it moves to the right, it'll keep going forever towards positive infinity. Range, however, again, down to up, this is going down forever. So the negative infinity must come first here. And the highest point would be at -3, and we would have to use a bracket for -3 because it is included on our graph. In other words, here it goes. That's how you should have written your answer for number 38. Okay. The last one we have to talk about is this equation right here. This is number 40 on your review. Once again, it's a parabola, so I know that the domain is all real numbers. The range, however, is restricted by this minimum. Because it's range, I want to use the 5, and I must write it down to up. So 5 is actually the lowest point, so that's the lowest y value, meaning it would come first, 5 bracket, and as it goes up, it's going to be approaching positive infinity, which would use a parenthesis because that's something that we cannot reach. Your answer should have looked like this. Okay, that should be all.